good.
The broadcast is now starting. All attendees are in listen-only mode.
So good afternoon or good morning, depending on where you are, and welcome to the July edition of the PASS Women in Technology User Group. And we are really, really glad that you have chosen to spend part of a great summer's day with us. And I will go ahead and tell you that anything that happens today is going to be recorded and it will go up on our YouTube channel this afternoon. So if there's anything that you missed, you want to see over, you can always catch it there. And I do try to get those uploaded by the end of the day. So our motto, encourage, energize, and empower those women that are on the call today. If you are able to be a mentor to someone, I want to encourage you to do that. If you'd need help finding a mentor, you can always reach out to us. We'd love to hear from you. And maybe we can help you find someone to mentor you in your career. The PASS Women in Technology User Group has two sponsors, Century One and Redgate. So it is an embarrassment of riches that we have. And at the end of this session today, we will give away 2 gift cards from those sponsors. You can check us out. Please don't bother to try to write down that link or memorize it. Just do a search on YouTube for PASS WIT and you will find us there. Please check out our homepage, wit.pass.org. We list all upcoming women speakers at SQL Saturdays, pre-cons, summit. If we know that some are speaking in a webinar, we try to highlight those as well. It's kind of one-stop shopping for a highlight of women in the data platform. If you join our virtual chapter from your login at pass.org, you will get our monthly newsletter, and that contains some of those links. It also contains some information that we think would be useful to you as women in technology. You can always follow us on Twitter, and we encourage you to both follow and use hashtag PassWit. For sharing information. And that's what we use when we highlight a lot of women speakers. So try to follow that hashtag. Upcoming SQL Saturdays, Albany and Birmingham are coming up. I have a wrong slide. Austin's supposed to be in here somewhere. Maybe I'll try to find it before we're over because there's a lot of women speakers at Austin, and I'm so pleased. Even one of their main organizers is a woman, so I want to make sure that I get that right. So I'll try to take care of that before we're done. Louisville as well is coming up. Upcoming session in September is Mala, and she's going to be doing a session on SQL Graph. Our August session is in the works. I don't have it scheduled, so I don't have a slide for that one. But today's session, I'm so glad Jess agreed to be with us, is I had actually had a couple of people approach me about this session, that they had seen it somewhere else and really wanted to see it again. And I think I was like, hold on, while one of them was talking to me, I actually just messaged Jess on Twitter and said, hey, do you want to speak for the WIT group? And she gratefully, I'm glad that she agreed. So she's going to talk about installing and configuring SQL Server with PowerShell DSC. So Jess, if you are ready, I'm going to go ahead and make you presenter. And we will let you get started. And again, I will be muted, so if you need something, give me a second.
All right, sounds good. You should be able to see my PowerPoint right now.
I can.
All right, good. That's a good start. All right, well, first of all, thank you so much for having me. I was pretty excited when you asked me to speak, so glad to be here. I will give one warning before we get started. This is going to be a PowerShell heavy session. The focus at the end is to install and configure SQL Server using DSC, but to begin with, we need to get a good understanding of what DSC is, and that's a lot of PowerShell. So bear with me. If you're not super comfortable with PowerShell, hopefully you'll be able to follow along well enough and still get a lot of benefit from this. So this is me. I'm Jess Pomfret. I am a SQL Server DBA. I currently live in Northeast Ohio, but I am originally from the south of England, so my accent is somewhere in between. Hopefully you can understand what I'm saying. I am an open source contributor, this is really how I got started on this journey of speaking and giving back to the community. I started contributing to dbatools and dbachecks, and more recently I have written a couple of resources for the SQL Server DSC module. That's actually a Microsoft PowerShell module that's open sourced on GitHub, so that's pretty cool. In my spare time, when I'm not doing tech things, I enjoy CrossFit to keep fit, and I enjoy proper football. I saw some tweets that there should be mentions of proper football, but I'm on kind of a downer from the Women's World Cup, so
a downer.
Still pretty sad.
What?
My England team, we've got knocked out in the semis again.
But then
I'm very excited for the US team.
You had a second chance to.
Yeah, I know. I know.
Celebrate.
I'm very excited for the US team. They did excellent, but
okay.
Still a little sad. But it's okay. We'll be all right. My contact information is on the bottom of every slide. I am on Twitter far too much if you ask my wife, so get a hold of me there. Or my email address if you have any questions, feel free to reach out. So our agenda for today. As I mentioned, the first section is going to be all about desired state configuration. We're going to talk about what it is, why we might want to use it, and then how we use it. Then once we have a good base understanding of what DSC really is, we can use that and apply it to installing and configuring SQL Server. As I mentioned, the first part is PowerShell heavy, but we will have an application on how we use that as DBAs in our SQL Server world. So the first thing to think about as we start talking about desired state configuration is why we would want to use it. And one of the concepts we need to think about is this infrastructure as code idea. So DSC gives us a framework to enable infrastructure as code. And when we talk about this, it's easier to think about our servers as VMs. I mean, most of our environment today is virtual, but it's easier to wrap your head around it if you think about your servers as being virtual and basically a script that will configure those servers, how many cores, how much memory, the disk layout. That's really going to be our infrastructure defined as code. And the idea is that we'll take that document and source control it. That is the most important piece on this slide, is that source control piece. Because as soon as we start checking in our infrastructure into source control, we start having this audit log of any history and any changes that are made are tracked. So once our documents are in source control, we can then work on some kind of pipeline, which is what I have shown on this slide. Those servers can basically be built from this source control script. You can run some automated testing against them, and then they'll be built or released into production by this cute little robot instead of by a human. So that's one of the benefits right there. Your humans don't need the same kind of permissions that they need to manually build servers because the robot or the release automation piece is going to do it. There are other benefits, like I mentioned, with source control, having that audit log, any changes are tracked and documented. It's also really easy to make this a repeatable process. If I build a dev server and I have it in source control and I've built it using this pipeline, when I go to move that to test or production, I have that already laid out. Any changes that have been made to that dev server to make it just as we need it should be in source control. So then when we move to the next environment, it looks just like that. One thing to think about in this, though, is if you have all of your servers in this kind of pipeline, this pipeline needs to be as secure as possible. This basically documents your entire infrastructure. So any kind of malicious attempt on gaining access, if they gained access to your pipeline, they now have basically the blueprints of your organization. Now, infrastructure as code is definitely a cultural change. You can't go back to work after this presentation and be like, guys, we're going to do infrastructure as code. All of our servers need to be in source control. The best way to kind of start thinking about this is to find a small project or a small proof of concept that you can implement it as infrastructure as code, kind of show some of the benefits, work through some of the nuances, and then kind of expand from there. So as I mentioned, desired state configuration is this framework that we can use with infrastructure as code. It was first released in Windows Management Framework 4.0, but it was greatly enhanced with 5.1. So if you're running an older server that has 4.0 on it, I would recommend manually upgrading that. Now, DSC is a PowerShell domain-specific language. Now, what that means is it is PowerShell, but it has its own domain of terminology and patterns within that language. So a lot of the code will look like PowerShell, but be a little different. We'll use this domain-specific language to create something called configurations, and those will manage the desired state of our infrastructure. The other important thing to note is that DSC is based on industry standards, so it uses the management object format and the common information model to really enact changes on your server. So the benefit here is that it can interact with other third-party tools that you can kind of plug in and use to manage your environment also. So when we think about DSC, we're going to think about it in these 4 stages. We're first going to author our document or write our configuration document that really describes our desired state. We'll then publish it where we push that, where we get that document out to each node. It'll then be enacted, which will be the make it so phase. And then once it's in the desired state, we're going to monitor it and make sure it remains in the desired state. So this is kind of the flow of the presentation, at least for the first part. We'll walk through each of these stages. If you have any questions, feel free to type them in the chat and we'll handle them as they come up or whenever it's appropriate. Okay, so step 1 is authoring our document. There are a couple of concepts we need to think about when we talk about authoring our document. So first of all, when we write PowerShell, we usually write imperative code, which explains the steps to complete the task. So you can see in my first, in the top half of the slide, you can see I'm saying new item, I'm giving it the path, and I'm giving it the item type. So I'm really telling you exactly what you need to make that happen, right? I'm leaving no option on how to do that. That's how that task should happen. Whereas with DSC, we write in more of a declarative way. So I'm going to describe my desired state or my end state, and then DSC is going to make it so. However, it's written under the covers. So you can see the equivalent in the bottom half of the slide is that I'm using a file resource, which we'll talk about in a second, but I'm basically defining that I want that folder ctemp to exist. I'm not telling it how to do its job. I'm just telling it how I want it to look in the end. So the other concept that goes along with this, and it's always a really good idea to put a word you can't really say in your slides. So idempotent is what we're going to talk about now. This means that we can apply the same configuration more than once because we're using that declarative language. We're just saying this is what I want the desired state to be. If I had used the imperative code of make that new directory, it would run fine the first time, but the second time I ran it, we'd see a sea of red. There would be all kinds of errors, basically. Well, that folder already exists, can't create it. Whereas with DSC, it would check and say, this is the desired state. Am I in the desired state? If yes, don't do anything. If no, make it so. So really, you don't have to roll your own logic or error handling around that. It's all baked into the DSC.
So
this means that you can make increment.
Really quickly,
Yep,
I'm sorry. I don't mean to interrupt. Somebody wants to know if this also works in Azure.
Yes, it does.
Thank you.
It works with like Azure VMs, not SQL databases, I don't think. But if you have an Azure VM, you can use DSC against that, yeah. Is there any other questions right now?
No, you're good. Thank you.
Okay, no problem. So this idea of being idempotent means that we can make incremental changes to our document and then push them back out. So anything that's already in the desired state won't be affected, but anything that is not in the desired state will be set that way. So as I mentioned about resources a second ago, this is really the building block of our configuration document. So resources are packaged as modules. If you have Windows Management Framework 4.0 or higher, you'll have this PS Desired State Configuration module already on your system with several resources already available to you. Let's pop over to my VM and I will show you that. Okay, so you should be able to see Visual Studio Code at this point, which is where I have my demos. The nice thing about PowerShell is it wants to show you how to use it. If you're familiar with PowerShell, you should know get-command, which helps you find commands that will do what you need, and then get-help to show you the documentation, the comment-based help on how to run them. So DSC resources are no different. We have this get DSC resource function that we can use to explore what we have available. So if I run this first command, hopefully that's big enough. Let me know if it's not big enough, but hopefully it looks okay. So within our first module, you can see I have all of these resources already built into my system and available to use. Here's the file resource, if you can see that I was talking about earlier. There are also resources for adding groups, for scripts, for registry settings, for services, or for Windows features, perhaps. These resources are what you're going to use to define your desired state. So once we decide that we want to use the file resource, we can use this same get DSC resource function, pass in the file resource and the syntax parameter, and it will return what we need to use in our configuration document to be able to use this file resource. And you can basically copy and paste this code that's returned. You'll use this file keyword, and then you'll pass in a string of a resource name. The resource name needs to be unique within your configuration document, but otherwise it's just using kind of, it should be named something useful so you know what it is, but it just needs to be unique within the document. Then you can see you have all of these properties that can be set. You can set the destination path, any attributes. If it's a file, you can add contents to the file. And then here's our type parameter where we were saying directory or file. So using the built-in help with DSC, you can kind of start to build your configuration just by exploring using this get DSC resource and then copying and pasting and starting to fill in those boxes. So as I mentioned, there's also some more information available, such as the path and the parent path. As I mentioned, these resources are all implemented as modules. And if I open this one up, I'm just opening the service resource PSM1 file. You can see that within each one, you have these three functions. There's a get target resource, a test target resource, and a set target resource. And those are the functions that DSC uses to manage your environment. So when you say, I want a directory to exist, it runs this test target resource function, and that returns either true or false as to whether it's in the desired state or not. If it is not in the desired state, it'll call this set target resource function, which will make it so. So all of the logic is inside the resource, and it's kind of under the covers from what you'll write. So finally, obviously that only gives us a few resources to work with. However, there are many more available in the PowerShell gallery. So you can use find DSC resource to search the PowerShell gallery and find other resources that you might want to use. So I know there's one called SQL Setup, but you can use wildcards in that to find resources. So you can see there's a SQL Setup DSC resource. It's available in the SQL Server DSC module. This is the version. I can then go ahead and pull that down and use those resources in my configuration. Okay, so as I mentioned, there's a bunch of additional resources available on the gallery. I've just pulled 3 modules to show you a few here. When I gave this presentation earlier in June, I did a count of how many resources were in the gallery, and there was 1,400 resources available for configuring different things in your environment. So on the left is the PS Desired State Configuration module. That's the one that's built in, so all of those resources are available as long as you have WMF. In the middle, we have the SQL Server DSC module that contains about 34 resources for configuring SQL Server. The first one is availability groups, so you can set up your availability groups using DSC, and they have some really great documentation on the GitHub page for this module that I can share afterwards on how you can do that. There's also everything else a lot of other things you could think of that you would need: databases, logins, memory, SQL setup to do the install. I've also added SQL Agent Operator on this list. No one else really cares about that one, but that's the one I wrote recently for the module, so I kind of like that one. And then finally on the right, I have the X Active Directory module. I pulled this one in just to show you that DSC is still pretty new and there's still a lot of development going on. The Active Directory module, it is still a Microsoft PowerShell module, but it does not reach their standards for being a highly qualified module. So it has the X for experimental in front of it. You can still use it in your configurations. You just need to be a little more mindful of any updates or changes because there could still be breaking changes in that module. So once we have our resources and we know which resources we're going to use to configure our environment, we're going to build that into a configuration document. And this is really going to be the main code that we're going to write to configure our environment. So configuration is actually a command type. So we're this will be similar to writing a function, but we're writing a configuration. I've named it create SQL folders, which is the name I'll use later on to call it. Within that, I can use import DSC resource, which is a keyword that can only be used within your configuration block. This will be used to pull in any resources that we need. Any of the modules that contain those resources will be pulled in here. Once we have that, we can look at our node blocks. So we'll have a node, we can have one or more node blocks within our configuration. And this is where we're going to define our target node. So in this configuration, I'm targeting server 1. You can have multiple node blocks, and you can also pass in multiple servers in that node block in an array notation. Then within our node block, we'll define all of our resources. So here's the file resource that we looked at earlier. I've named it create data directory. As I mentioned, that has to be unique within your configuration, and it's good to make it something that you know what it is. So if it shows up when you're troubleshooting later on, you know exactly which resource there's an issue with or you need to look into. Then finally, we have our properties, where this is basically defining our desired state. So the destination path, the type, and the fact we want it to be present. Okay. So once we have our configuration written in that domain-specific language, we'll take that configuration and run it. We'll call create SQL folders, and it will generate a MOF file. The MOF file is what is passed on to the node and is what is enacted. So it takes that kind of easier to read, human readable document and compiles it into this MOF file. So when you call your configuration, you'll end up with one MOF file per node. There is something called partial configuration where you can have more than one MOF per node, but it is complicated, and I've played with it a little bit, and there's a lot of writing online that suggests it's a little more complicated than is perhaps needed. So it's best to stick with the one MOF per node idea. As I mentioned, since it is idempotent, it can be modified and reapplied. So we'll just have one configuration document. We'll make changes to it, we'll recompile it into a MOF file, and that MOF file will be used to make sure we're in the desired state. All right, so let's go ahead and write a configuration. All right, pull this down a sec. So here's a pretty simple configuration. It's very similar to the one I had on my slides. We are importing the resources from this PS desired state configuration, and then we're going to target the two servers that I have on my laptop, just little VMs running DSC Server 1 and DSC Server 2. I'm going to create two directories. First, this data directory for my data files, and then I'm going to create a log directory for my log files. So if I execute this, you'll see nothing really returns. It's kind of like if you write a function and then you execute the code that makes that function. It doesn't call it, it's just now there. So if I check out my commands of command type configuration, you can see the configuration I just wrote is here, create SQL folder. Now when I call that, I'm going to pass in an output folder, and that is where the MOF files will end up. You can see that it's returned that it's created two MOF files, one for each server. If I open them up, you can see that it's still kind of readable. You can see here's my file, create data directory, there's my path, but it's the format of this is very important, and although you can modify it, it's recommended that you don't, that you use the configurations or you use a third-party tool to create these MOF files. Right, I'm going to clean that up. So that was our first configuration. We created a MOF file that can be used to define our target node. Now that was a pretty simple example, and obviously in the real world things are going to get a lot more complicated than that. One of the ways we can handle that is using configuration data. Now this is going to give us the ability to separate the data from our configuration file. And when I say data, I mean things that are hard-coded, like server names, the paths to my directories, any settings in SQL Server, perhaps. I'll then be able to use that same configuration document for all of my environments, but as I pass, configuration will be slightly different for each environment, if that makes sense. I'll show that in an example in a second. The configuration data, it's a common parameter. It's on all configurations, and you'll pass in a hash table similar to the one in the green box. It needs to have an all nodes key, but it can also have non-node data that you can define inside the hash table, but outside of the all nodes key. Okay, so what we're going to do now is we're going to take the configuration that we just looked at and change it to use configuration data. Okay, so here is my configuration. I have changed it slightly from how you saw it a second ago. I'm now using the all nodes node name property of this all nodes hash table to affect all nodes. Now this one is going to hit all nodes. You can also use PowerShell down here. So I'm saying all nodes, but I'm using the where method to say if the environment is test, this node block will apply to those servers. I'm also using the configuration data on the whole to get to the non-node data where I have my data directory, my log directory, and my test directory defined. So if I take a quick look at this, you can see I have my all nodes key. I have one server, DSC server 1, it's a test server, and then I have my 3 directories listed here. So if I go ahead and run this, actually I think I can run the whole thing. It'll compile that configuration, and then I've called the configuration, passing in my configuration data, which is in a separate PSD1 file. And I've got one MOF file returned. So if I take a look at this MOF file real quick, you can see that I have my file create data directory here. I then have my file create log directory. And finally, because it was a test server, I have my file create test directory. Now that we're ready to move to production, I can come into my configuration data and I can add an additional node to my node block. I'm going to call it DSC Server 2, and we're going to production. I also, in my testing, decided that we were going to go with 2016, so I'm going to rename these folders. Now, when I come back to my configuration, all I need to call is the actual call to the configuration, passing in the configuration data. I don't need to recompile my configuration. And you can see now I've got 2 MOF files created because we added that second server. If I go into DSC Server 2, which was the production server, you'll see we have file create data directory, file create log directory, and that's the end. Because I defined this server as production, the configuration didn't apply that test folder. You can also see that the name has changed to SQL 2016 since I made that change, and it will be changed on both MOF files. They were both regenerated. All right. So kind of pulling that configuration data gives us a lot more flexibility on how we can define our configurations and then how we can make them behave slightly different per environment. So that is authoring our documents. We've written our configuration and we've compiled it into our MOF file. So the next step is to publish it. We need to take that MOF file and we need to push it out or get it out to our target node to enact. So there are 2 modes for DSC. We're going to talk about the push mode today as it's simpler and easier to set up. And once you start as you start playing with DSC, you'll probably start using the push mode just to play. Once you get a little more comfortable, you can look into the pull mode, but you don't have to. You can use DSC in a push mode at an enterprise level. So the push mode is when you're actively going to apply a configuration to a target node. We're going to actively push that configuration or that MOF file out. This is the default refresh mode, and it's, as I mentioned, simple and easy to use. The reverse or the opposite is the pull mode, which is where you register your nodes with a pull server. It can be a local service set up on a Windows server or an SMB share, or you can use Azure Automation for this. You register your node with that pull server, and then your configurations are pushed out to your pull server. Then those target nodes will check in, see if there's any new configurations, and pull them down and apply them. So we have a couple of options of ways of getting our MOF file out to our target node. We can use Start DSC Configuration. This will deliver the MOF file to the node and make it so immediately. I'll give it the path to the MOF files, and I can give it a computer name if I only want to apply one or several of the MOF files. Otherwise, it'll apply any MOF files in that directory. I'm also using the wait and the verbose parameters in the background, and you'll have to retrieve that job to see the result. The other option we have is Publish DSC Configuration. This will deliver the configuration out to the node, but it won't immediately apply the configuration. There are some settings that we'll look at in a second that will determine when that will be applied. So once we have our MOF file pushed out to our target node, this is where the magic happens. This is where it's the make it so phase or the enact phase. Now every node that has WMF 4.0 or higher has this local configuration manager. This is really the engine of DSC and is responsible for receiving those MOF files, parsing them, and enacting them. This is where all of your settings for DSC will be configured also, which includes that refresh mode that we saw earlier. So if we're in pull mode, we set our local configuration manager up to know that it's in pull mode and where it's configured, where it's registered, its pull server, where it should check for configurations, etc. As I mentioned, there are a lot of settings that you can set on your LCM. I've just pulled a few of them here, but I'll make these slides available. I think actually they're probably already on my GitHub. And there is links in here on where all of the configuration settings are. But a few that are important here, the refresh mode, as I noted, push versus pull. Your refresh frequency minutes is how often your node would check in if it is in the pull mode. Like, should it look for a new configuration every 15 minutes, every 2 days? The reboot node, if needed, is kind of an important one to note. It is false by default, but if you set that to true and you push out a configuration that sets something that causes a pending reboot, your node will reboot and then come back up. Then you can set your action after reboot to continue with your configuration or to hold. That's pretty useful if you're building an initial server, but if you have a server in production, you probably want to make sure that reboot node, if needed, is false, unless you're comfortable with that server rebooting when you change something. The other one I want to mention on here is certificate ID. You should encrypt your MOF files, and I'll show you why later. But this is where you would register the certificate that you used to encrypt your MOF files. You would give the certificate ID to the LCM so that it could unencrypt and use that MOF file. So to configure our LCM, we actually write a similar document to our configuration document. So let's go ahead and take a look at how we do that. Okay. So I'm going to go ahead and get my current settings for the LCM on the other server that I have on my laptop, DSC Server 2. You can see there are a lot of settings available. All of these can be changed by using the meta configuration. So I'm just going to grab a couple. The action after reboot, we're going to continue. The refresh mode is set to push, and this configuration mode frequency minutes is currently set to 15. So in my example here, I want to change that setting to 20. Now you don't need to list multiple settings if you're not changing them, but in this example, I'm just changing this 20. So I'll do the same as I did previously, where I will run that configuration to create it, and then I can call it using that output folder. You'll see that we got server name.meta.mof, which means it's a meta configuration and will apply to the LCM. I'll then use the set DSC local configuration manager with the path of output and the computer name to push that MOF file out and enact it immediately. You can see this is completed. And if I recheck my settings, you can see now the configuration mode frequency is set to 20 minutes. So that was a quick example of how you'd set up your LCM. If you had that certificate set up, you would do that the same way with having a certificate ID setting in here. Pushing that through. Okay. So target node, the LCM is set, and we've pushed out our MOF file, so we're in the desired state at this point. The next step is to monitor. I'm not going to go too much into this. I do have a demo that I'll include in the downloads of how to walk through this, but I'll just talk you through it right now. The first command, get DSC configuration, is going to get your current configuration of your node. It's not necessarily, though, going to tell you if it's in the desired state. If I push out a configuration that creates a folder, it will say there's a folder and it is present. If I delete that folder, it will say it's absent, but it will not tell me that that isn't the desired state. The next command is get DSC configuration status. That'll give you the configuration status for the completed runs of DSC. Was my job successful? How many resources were enacted? That kind of stuff. To test the current configuration, you'll use test DSC configuration. You have a few options on that. If you just run it with just the computer name, it will return true or false, which isn't super helpful if it says false, but it doesn't tell you why it's not in the desired state. You can use the verbose switch. That will return all of the DSC output, and you can read through that and find where it's not in the desired state, but it's still kind of difficult to pinpoint if you have a large configuration. Finally, you can use the detail switch, and that will return a PowerShell object that you can then manipulate and find your resources not in the desired state. One of the difficulties with DSC is that it is kind of difficult to troubleshoot. So one of the things you want to make sure is that you know where these event logs are. So on your target node in the event viewer, the path is application and services log, Microsoft Windows desired state configuration. The first two logs, operational and admin, are enabled by default, so you can go there to look for keys or to why it may be failed. If you need more information, you can enable the analytic and debug logs, rerun your configuration, and then check there. They get a lot more information, which is why they're turned off by default for performance. Okay, so that was our whistle-stop tour of DSC, why we might use it, how we might use it. We're now going to apply that to SQL Server. This is a good point for any questions on DSC, if there is any.
So the one that I have is they wanted to know what editor that you were using.
Oh, it's using Visual Studio Code. It is a Microsoft free download. There's a PowerShell extension. It's super useful. I will tweet out a link after this if
Awesome.
That would help.
I appreciate that. Thanks.
Sure. All right. Any other questions, or shall we go install SQL Server?
Nope, that was it. You're good.
All right. Okay, so as I mentioned, I'm a DBA. I work with a lot of small applications that require SQL Server databases, so I get a lot of requests to build new servers. So when I get a request, I currently have this checklist of all the things I'm going to do before I hand off this server for the application to be installed. So I'm going to install Windows features if I need them. Perhaps it's an older version of SQL Server and I need the .NET framework installed. I'm going to create directories for my install install files, my data, my logs, my tempdb. Then I'm going to install SQL Server. I'm going to enable TCP/IP, set the Windows firewall up so I can connect remotely. And then I have a few server configuration options. These are all from if you used SP Configure to set backup compression, cost threshold for parallelism, and maxed up. Finally, I'm going to create a DBA database for me to put the OLA maintenance scripts in. So this is currently the process. It was pretty manual. You would go through each step and kind of check it off. So what I did was I took this and I mapped it out to which resources I would need to use to be able to do those same tasks using DSC. So first off, the first two are from the built-in PS Desired State Configuration modules. I can use the Windows feature resource to install .NET, and I can use the file resource to create directories. Then I need to pull in the SQL Server DSC module, so I can use SQL Setup for the install, SQL Server Network for the enabling TCP/IP. Then on the firewall, on number 5, you can see I have two options. I can either use the SQL Windows Firewall resource, which is part of SQL Server DSC, or if I want more flexibility, I want to name it something specific, I want to lock it down to certain hosts or something, I could use the firewall resource from the networking DSC module. So it's important to remember there are multiple ways of doing some of this stuff. Just something to think about, something to remember. There might be another module that would do what you need. Finally, I have SQL Server configuration to set those properties, and then SQL database to create my database. So let me show you my configuration. Pull that down a second. All right, first off, I'm going to run this get SQL. I'm going to run get service and check for SQL services running on my target node just to prove that I have nothing running. The other server does not have SQL Server on it right now. So to get this rolling, I'm going to execute this whole file. It's going to ask for my password for SA, and I'm going to type something super secure. Okay, so while this is going, we'll go through the files. So hopefully it will create me a moth file. Yep. So here's my DSC Server 2 moth file that was created. This looks pretty similar to the ones we already saw. The resource names and the settings for each one. The reason I wanted to show you this is that my password for my SA credential is in here in plain text. Now, I mentioned earlier on you'll want to encrypt your moth files. This is why. If you don't encrypt your moth file, any password is in plain text in here. And that is a huge security risk because this moth file is living on my authoring station and on my target node with that password. Now, I did have to jump through a hoop to be able to let DSC write that plain text password, and I'll show you that in a second, but just something to think about if you're using this. These need to be encrypted. So let's take a look at my configuration data. As we saw previously, we have this all nodes key, and I have two servers defined. I have DSC Server 1 and then DSC Server 2, which is the one we're actually going to enact on. The DSC Server 1 I'm on currently. So we're just installing SQL on one box. I then have this node name of asterisk. This means that this section will apply to all of my target nodes. And this is the hoop I had to jump through to get that plain text password. If I run it without that, it says, hey, your moth file is not encrypted and you have not said I'm okay to use plain text passwords. So it does make you think about that. It's not just going to put plain text passwords in there by default without you knowing. So after that, I have my non-node data. You can see I've listed out my data directory, my log directory, my install directory directly under my non-node data. The other way I could do that, or the other design way I could structure this, is to have config options as a nested hash table, and then have the settings within that. And I'll show you why I've done that differently in a second. But these are two options for listing non-node data. That's all I have in here right now. These are the settings I want to set and the folders I want to use. So if I come back to my install, it's going to look very similar to the simple one we saw earlier, just with more resources. I'm pulling in my SQL Server DSC modules so I can use those. This was the pop-up you saw for me to get a credential, to get that password for my essay. And then here's my node block. This is going to happen to all nodes that are listed in my all nodes key in my configuration data. And I have this first one commented out. I'm installing SQL Server 2017, which doesn't need .NET, but I just wanted to show you that's how you would write that. I then have my file resources using this configuration data, non-node data install directory. And this is because I listed them right under non-node data, that I've had to call them out individually. I'll show you in a second how I did it for the config data, but this is just one option. Then you can see my SQL setup resource. I've named it install SQL. I've given it the instance name of MS SQL Server, which is just default instance. This is the source file for my installation. I'm installing the SQL engine. I'm making myself a sysadmin. Here are the folders I want to use for my install, my logs, my data. Security mode of SQL is mixed mode authentication, and then because of that, I've passed in my SA credential. I then have my enable TCP IP using the SQL Server network resource. I'm just opening up, I'm just setting SQL to use TCP IP on 1433. I'm allowing it to restart the SQL service so that works. And then I'm using my SQL Windows firewall to set up a firewall exception for SQL Server. This block right here is going to look a little different, and I'm using the config options hash table that was in my non-node data and some PowerShell logic. I'm using the for each method to loop through anything in that config options hash table and create resources. So for each one, it will create a SQL Server configuration resource named set config option and then the name of the config option from the hash table. It'll then set the option name. So this will be like backup compression and the option value to 1. So however many items I had in that config options hash table, it would create the respective number of resources on this side. Then finally, I have my create DBA database. I'm using the SQL database resource. I've named it DBA. There's nothing too crazy in there. There are also resources for setting the owner and some other things. Some other things to mention, there is a depends on property that is available on all resources. That is basically saying this resource can't happen until the one it depends on has happened. So in WMF 4.0, that was really important because it didn't read it from top to bottom of your configuration file. It just enacted them in a way it felt like it wanted to. But it's still important today because if my SQL setup failed, I don't want to create a database because there's no point creating a database if the instance isn't there. That's going to fail also. We also have PSDSC run as credential available on all resources, which by default, the LCM runs the configuration on your target node as the system account. So if you want to run it as, say, my domain account that has access to file shares or local registry settings, I can use that PSDSC run as credential. Okay, so good news. My SQL Server has finished installing. It took 6 minutes to install that SQL Server, which is pretty cool. And it's not just installed, it's configured exactly the way I want it. So if I refresh this, you can see that I have the DBA database that I created. And I'm using Azure Data Studio for this. And if I connect this, and I'm just turning on the advanced options using SPConfigure to show you that it has changed this cost threshold for parallelism. It's now set at 25, which is what I set in my configuration data. So it installed this server. I can connect to it remotely from DSC Server 1. My database is there, my settings are there, and all that happened in 6 minutes without really having to do too much configuration for this specific server, right? Which is pretty cool. So as I mentioned, this is, you can make incremental changes, right? So if I've perhaps read a really great blog post earlier that suggested I set my cost threshold for parallelism to 500, I didn't. It's not a good idea. This is not a how to set your SQL Server up. This is just showing you how you could. 500 is not a great number for that, but I can change that in my configuration data. I could also make changes if I needed to my configuration document. If I wanted to create a second database, for example, perhaps I need to create a Women in Technology database. I need to change this name because it needs to be unique within my document. And then I'll just set this to be Women in Technology. I'll highlight all of this since I made a change to that configuration, and it's going to ask me for my SA password just because I have that get credentials set up there. So I'm now executing. I pushed out my MOR file again using start DSC configuration, and it's going through each resource now and testing it. So is there a directory created for my log files? Yes. Okay, don't recreate it. Is SQL Server installed? Yes. Okay, move on. Then it will get to this final bit and say, is there a Women in Technology database? And it'll say no, so it'll create it. Let me just show you. The DSC output is not always the easiest to read, but you can see each resource starts with the start resource text. It's starting the DBA database. It then will run the test function. So within that resource, remember how we had multiple functions? This is running test to check if the database name DBA is present. You can see down here it said it was present. So because it's ended the test saying it is good, it is in the desired state, it will skip the set and that will end the resource. It'll then move on to the next resource for create Women in Technology database, and it'll run the same test. It will say that SQL database name WIT is absent. So because of that, it will start the set phase, and it will add here, create ends the resource, and that was the last one, so it's completed. So if I come back to Azure Data Studio and refresh this, you can see I have a new database created. And if I rerun my cost threshold for parallelism, you can see that it's now set to 500. So one of the benefits of that is if this is source controlled, I had to check this in, right? You can see that Visual Studio Code has picked up that I've made a change on this setting. And for me to save that and put it back into source control, I would have to write a commit message on why I changed that setting to 500. You would then have the exact point, who made, like the point in time that the change was made, the change that was made, who made it, and a commit message. And as long as I didn't write stuff or fixed it, there's a useful audit log of changes that were made to your SQL servers. So when I noticed that Tuesday lunchtime, our performance suddenly dipped, and we're starting to see problems, I can go back to my source control and I'll be like, oh, Jess made a change that was documented, and this is why. That didn't work out. I can put it back and push out that configuration. So this is really powerful for keeping track of your infrastructure and any changes, as well as just installing SQL servers pretty fast. So if you got super excited about this, I've got some next steps on this slide. As I said, DSC, we could spend like all day talking about it at least. But the next steps to think about, I will say it again, that source control piece is really cool and something that could be really useful. If you can get your configuration or even just the documents that define your infrastructure into source control, you can start getting that history and that kind of audit trail around them. The CI pipeline, once you have stuff in source control, you can look at building it out with automated tests, perhaps using pester tests to ensure any changes aren't going to have adverse effects, and then pushing them out automatically. In the middle, I've listed Chef, Puppet, and Ansible. Those are some third-party other products that you can use either to do configuration management without DSC or in partnership with DSC. Some of those have some really good reporting functionality that DSC doesn't have as much of right now. Finally, the bottom section, just some other topics that you can look up. Datum is the really cool PowerShell module written by Gail Coles, I think his last name is. But he basically implements this idea of having hierarchical configuration data, because once that configuration data starts getting bigger, that document gets kind of out of control. So this idea of having it in a hierarchical form is pretty cool. Also, Azure Automation, you can use that for to be a pull server. You can then manage your DSC artifacts, your configurations, your modules, your nodes, all within Azure. And you can register Azure VMs, other cloud provider VMs, or your on-prem VMs with that. The final one to mention is reverse DSC. This is a really cool idea that someone built for SharePoint specifically and for SQL Server, like the back end of SharePoint. It is still a little, like there's still a lot of room for improvement on that to make it kind of fully encompassing of your SQL servers, but the idea is that you point it at your SQL server and it reverse engineers the configuration that you would have used to create it. So that's a really good way of getting your current servers into source control without having to rebuild them using DSC. So we've made it to the end. We have a few minutes for questions if there are any. If there are not questions right now and you suddenly think of one late at night and you can't sleep, feel free to email me. I have a few DSC blog posts on my blog at jesspomfret.com, and my demos are up on GitHub already with the slides.
So the questions that we did have pop up, people followed up with, never mind, she answered it. So
well, that's good then.
Right? So you were good that they got the answer in, like, usually the next slide it would appear. So
perfect.
So yeah, we are good to go. Jess, again, thank you so much for having this.
No problem. Thanks for having me.
And I think we're good. So I'm going to stop the recording here in just a second. Everybody that's listening, this will be uploaded to YouTube later today. And Jess said she would tweet a link out with the editor that she was using. And
yep.
So I think we're good to go. And again, thank you so much for doing this. And a couple of you should expect to get an email from me regarding winning an Amazon or a Visa gift card. So thanks again, everybody, and have a fantastic day.